Next, we're gonna talk about the different bone cells, then we'll go into hematopoiesis, fractures, and homeostasis of calcium control, level control. So here are the different bone cells. Osteoclasts. These break down the bone, and they're also breaking down the cartilage when the cartilage is turning to bone. Osteoblasts, instead, these were the builders. And so they build the bone, and then once they build the bone and become surrounded by bone, they're called osteocytes. Bones continue to grow in length as long as cartilage cells are remaining active there. Yeah, so then when it says here, when the cartilage has turned to bone, then the bone can no longer grow in length. But later on in life, well, throughout life, bone remodeling. This is very important for us. It occurs throughout our lifetime. What does this mean? It means that old parts of our bone are replaced with the new bone. So if this didn't happen, then our bones would be very weak and fragile. But yeah, so of course the bones that you use more, often, they're replaced more often. But yeah, 10 to 20% of our skeleton is replaced each year. So bone remodeling includes two parts. Bone resorption, well, you need to get rid of the old parts of bone. And so know that bone resorption means removal of bone, and know that osteoclasts are breaking down the bone. Well, then we need to replace the parts that we took out with new bone. So bone deposition means forming a bone, building bone, laying down the bone, and this is done by osteoblasts. In order for our bones to grow, but also later on to maintain the bones, we need different vitamins, growth factors, hormones. Vitamin D, this is important for calcium absorption. Vitamin A is important for osteoblasts and osteoclasts to work properly. Vitamin C is important for collagen synthesis. Growth hormone, this is important during childhood and adolescence, but it stimulates the cartilage cell division so that the bone can grow in length. Not having enough results in dwarfism, but this is pituitary dwarfism. If growth hormone is supplemented, then that will actually fix the issue. Now, sometimes if our pituitary gland releases too much of this growth hormone, it can lead to gigantism in the child. This can be due to a tumor. Now, later on in the adult years, if the pituitary gland has a tumor, that can cause the pituitary gland to release a lot of growth hormone. If this happens, it leads to acromegaly, meaning here the bones end up growing, not in length, but they become wider in different little parts. Then know that thyroid hormone is important for growth, for osteoblasts to work properly. Estrogen, testosterone, these are important for the growth spurt. So for that epiphyseal plates to turn to bone. Then physical stress. Now, this means, for example, exercising, weightlifting. So the more you use your bones actually become thicker and stronger. Next, a little bit about fractures. There are simple versus compound fractures. Simple means that the skin has not been broken, but compound fracture means that after the bone breaks, the bone has gone through the skin, and so here the skin is now open. And so just know that broken bone or bones stick out through the skin. And so this is an open wound. Different types of fractures. I don't ask these specifically, but I'll just go through them. Green stick fracture. This is seen in children because they have more collagen fibers. So here the break is not complete. Next to that, fissured fracture. This is an incomplete longitudinal break. Comminuted fracture. This is when the bone breaks into pieces. Transverse fracture. So this meant going across. So when the bone breaks, just across. Oblique fracture. This is a diagonal break. Then a spiral fracture. This is caused by twisting of a bone. How does the bone repair itself? 4 main steps are involved. Hematoma means a blood clot forms. Because when our bone breaks, the blood vessels inside break as well. And so here, we need to stop the bleeding. So blood clot forms here to stop the blood from coming out. Then next, in the part that is broken, cartilage is laid down. So it's actually fibrocartilage. So this cartilage acts as a scaffold for the new bone to be deposited. Bony callus, this one the osteoblasts come in, lay down the bone. Finally, remodeling is to fix any mistakes that were made when the bone was being laid down. And so if you see on this picture, it doesn't look right, but so after remodeling, it's mostly back to normal. Except that where the bone was broken before, you can see how it sticks out on the sides. So this can be seen on x-rays, especially if the bone did not heal properly. The different functions of bones, we'll go through these. Bones provide shape to our body. They help support us. They protect our body structures, the organs inside. Bones are, because they're on the outside. Bones help with movement. Then we're going to talk about how bones, the bone marrow is helping to produce blood cells, and bone is also storing those minerals. Okay, so hematopoiesis. You know what this means. It means making blood cells, so blood cell formation. Making blood cells occurs in the special tissue called the red bone marrow. Okay, not the yellow marrow, because that was just fat. Red marrow is found in the spaces of our spongy bone, especially in our hip bone and the sternum. In children, though, you can see red marrow inside the marrow cavity or the medullary cavity. And so here, the tissue is making red blood cells, white blood cells, and the cells that will turn into platelets. With age, some red bone marrow is replaced by yellow marrow. Okay, so our bones hold a bunch of minerals inside. These minerals together is just called the hydroxyapatite, so calcium, phosphate, but other salts as well. Osteoporosis. Osteoporosis means loss of bone mass. But what does it mean actually? How does that happen? Now, here with osteoporosis, bone resorption is occurring faster than bone deposit. Why? Here, osteoblasts, they need estrogen and testosterone. So in women after menopause, estrogen levels have decreased, but in men as well, testosterone slowly starts to decrease as men get older. And so here, osteoblasts lose their function slowly. Osteoclasts, they don't care about estrogen, testosterone. They still want to keep on doing their jobs. They want to get rid of the old parts of bone, but it's the osteoblasts that are not doing their job as well anymore. And so bone formation is diminished. Another function of bone is calcium regulation in our body. So calcium is not only needed by our bones, but also needed by our muscles, nervous system, and for our blood clotting mechanism. Now, if those parts of your body are not getting enough calcium, if you're not consuming enough calcium, then, you just take it out of your bones and send it to those parts. So if blood calcium is low, PTH, the hormone released by the parathyroid glands, because PTH actually stands for the parathyroid hormone, this special hormone activates osteoclasts. Well, when you activate the osteoclasts break down the bone. And when you break down the bone, calcium is released out of the bone and sent into the bloodstream. Now, what if the opposite is happening? What if the blood calcium is high? Well, if you have enough, and if enough is going to those organs that need it, well, then you just store it in your bones. So another hormone called calcitonin that is released by your thyroid glands are used instead. This hormone activates the osteoblasts. Remember, osteoblasts are the builders of bone. So when these are activated, osteoblasts put the calcium into the bone. So having very high levels of blood calcium is not good. So you need to store it in your bones because high blood calcium can lead to kidney stones, heart problems, digestive problems.